Hey everyone, Loksu here, and we're back with another tutorial covering DMX stepper motor controllers. This time I'll be showing you how to build a controller that uses DMX to manipulate the position of a stepper motor. I'll be sending the DMX signal from Touchdesigner, but really you can use any kind of DMX controller or software once you have this hardware built. If you're looking to build a continuous rotation motor with speed and direction control, I'll put a link for that tutorial here. Before we begin, I want to mention that this design is an open loop circuit. There are no encoders or limit switches included for position and end detection, so it won't remember the previous 0 position whenever you power cycle the controller. Whatever position the motor is currently at during power on is going to be the new 0 position. I plan to make an updated version with position sensing, but for now I wanted to make this as simple as possible to help you get started with DMX control. So with that said, let's get started. First, let's briefly go over the hardware setup. This is an Arduino Uno with a DFRobot DMX Shield attached to it. This XLR cable connects to the DMX USB interface, which is connected to my computer. Here on the stepper motor driver, pulse negative connects to pin 5, and direction negative connects to pin 6 on the Arduino. The positives are tied together and connect to the microcontroller's 5-volt pin. The stepper motor is connected with these 4 wires, and the driver is connected to a 12-volt power supply. Using the table provided on this driver, I configured the dip switches to have 800 pulses per revolution and set the current limit to 0.5 amperes. You may need to increase this current limit depending on the stepper motor you are using. You can also change the number of microsteps for your setup, but keep in mind that one DMX channel is only 8 bits, which means the data range is an integer from 0 to 255. This limits the control to 255 positions. It is possible to create a 16-bit value for more precision, but I'll be keeping this version simple by having one DMX channel for position, one for speed, and one for acceleration. One more thing to keep note of is the MAX485 chip on this board uses serial interface to operate. So anytime I want to reprogram this board, I need to move this first jumper from the EN to the EN with the bar over it. Doing this will disable the MAX485 chip and use a serial interface to communicate over USB. After I'm done programming it, I need to move that jumper back to EN in order to receive DMX signal again. So now let's go over the Arduino code for this project. I'll also make this file available to download on my Patreon, so please consider joining to support my work as I continue to share more projects and tutorials. So here at the top we include 2 libraries used for this project. If you don't have these installed already, just go over here to the library manager and search for the library and then click install. Here the 2 pins attached to the motor driver are defined. These numbers correspond to the physical pins used on the Arduino. This first variable will say which DMX channel to be listening on. Because this is the only fixture on my DMX universe, I just set it to channel 1. But if you have multiple DMX fixtures or hardware connected, then you would change this to an available channel so it doesn't overlap with other fixtures. These 3 variables will hold the incoming DMX data. Below that are the 3 variables to hold the scaled values of that incoming DMX data. The reason we do that is because the incoming DMX data is an integer with a range of 0 to 255, so we have to rescale this data to the actual range that we need. This final group of variables defines the maximum position, speed, and acceleration. These will be used to scale the incoming DMX data. As you remember from the first part of this video, my motor driver was set to 800 steps per revolution, so by setting this to 800, this will make my motor rotate from 0 to 360 degrees. You can easily change this to say half or double or whatever number you want. All you need to do is take the number of steps per revolution that you set on your driver and calculate the number of steps needed for your desired rotation. For example, at 800 steps per revolution, if I put 400 here, then my motor can only rotate from 0 to 180 degrees. But if I change this to 1600, then my motor will rotate 720 degrees, which is 2 full rotations. But for now, I'll just do 800. For the maximum speed, this was based on some information that I found online saying that it is limited due to the Arduino's clock speed of 16 MHz. You can also make this value smaller if you want. This line is where we define one stepper motor. It is configured as mode 1 because this motor driver uses a pulse and direction signal. In the setup section, all we need to do is initialize the DMX serial interface and set it as a receiver. Okay, now let's come down here to the loop section. What's happening here is it records the time since the last DMX packet was received. It then checks if that packet is less than 5 seconds old. If it is less than 5 seconds old, the data from the packet is stored here in these three variables. The first channel will be used for position, the second for speed, and the third for acceleration. Then the DMX data is remapped and stored in these three variables here. So with the incoming range of 0 to 255, we scale that to a range of 0 to the maximum values that we set from the beginning. Then we tell the software to set the maximum speed and acceleration with those stored values. And then we send a command to move the motor to the calculated position. This final command, run, pulls the motor driver and tells it to take one step if it is due. During this time, it is calculating the speed based on the acceleration and the maximum speed allowed. What's great about this code is that it is non-blocking. That means that it will move the motor to its destination, calculate the speed based on acceleration, and still check for new DMX data at the same time. This allows us to change the position, speed, or acceleration at any time, even if the motor has not reached its destination. Okay, now let's go here to the top and make sure we're connected to the Arduino Uno and using the correct port. And then we can go ahead and compile the code and upload it to the Arduino. Alright, it finished programming with no errors, so let's put the DMX Shield's jumper back to the enable and begin listening for DMX data. Alright, now let's hop over into Touchdesigner and create a system for controlling and sending the DMX data. Let's start by making a base. We'll call this base Stepper Position Control. Let's right-click it and go to Customize Component. Let's make a page and we'll call it Control. For a parameter, let's make an integer, and we'll call it Position. We have to change the range max to 255. Let's make another parameter, and we'll call that one Speed. And then change the range max to 255. And then we'll make one more parameter and call it Acceleration. And this one we should also change the range max to 255. Let's make another page and call it Settings. Here in the Settings page, let's make a parameter and call it DMX Address. For the default, we should make it 1, range min 1, and range max 512. Now let's go inside the base. First, let's start by getting a parameter chop. After the parameter, let's make a select. In this select, I want to select only the DMX address. And then I'll copy that select. And then this time I want to select everything except for the DMX address. So what I can do here at the channel name, I could put a caret before, which means not. And so you can see now it's selected every channel except for the DMX address. Here in the first select, let's add a null. And we'll name this address. And then here on the second select, we'll make a null. And I'll call that one channels. Let's make a rename. We're going to use a little bit of Python to automatically rename these channels for organizing the DMX data. So here in the To section, click the blue box for expression, and I want you to type the following code. What's happening here is it's automatically renaming each channel to start with the CH, and then it attaches a number at the end of it, starting at 1 until it reaches the range maximum. But right now you can see that if I go to the settings and change the DMX address, these channels are not updating correctly with it. So this first number here, it should be the starting address value. We can get that by pulling the value from the address chop. This second value should be the starting DMX address plus the sum of the number of channels that we have for this fixture. Now when I change the starting DMX address, you can see that the channels will automatically update with it. So if I have the address at 153, you can see the starting one is 153, and then it increases by 1 for each channel. Let's attach an out. And then let's back out to the main project. Okay, now here let's make a constant. For the name, I'm going to write CH with a range of 1 to 512 in brackets. It's really difficult to see here, but what it's doing is it's creating 512 channels with a value of 0 as the base DMX universe data. Now let's make a replace. Let's connect the constant into the first input, and then we'll connect the controller into the second input. After replace, let's put a shuffle. Here for the method, let's change it to sequence all channels. After the shuffle, let's put a rename. I'll rename this channel to DMX data just to make it easier for organizing. And then let's put a DMX out. Here in the format, we have to change it to packet per channel. So now if I go over to the stepper motor controller, and if I go to the control page, I can set the speed and acceleration, and then if I set the position, you can see that the motor rotates to that exact position. If I make the acceleration a smaller value, the motor will slowly ramp up as it rotates to the position. Or I can even set the speed to a slower value. You can control multiple motors with this by making a copy of the controller base and merging it with the output before the replace chop. Just make sure that the starting DMX address is 3 channels greater than the previous one, or else there's going to be some conflict with the data mixing. I'll also show you a quick tool that I made for testing the motor. So here what I can do, I can select the speed and acceleration by percentage, and then I can select the position by number of degrees that I want to rotate to. I'll leave this tool included in the project file where you can download it from my Patreon. I hope this helps you get started with making your own DMX motor controller. If you have any questions, please feel free to leave a comment in the section below. The final project files with comments are available on my Patreon, where you can download and use for yourself, and also have access to other projects and tutorials that I will continue to share online. So if you enjoy these kind of tutorials from me and wish to see more, Patreon is the best way to support my work, and please like this video and subscribe to my channel. Thanks.